Hello, here's our second example. We're looking at those extreme values and increasing and decreasing intervals. It's a little bit different, but similar ideas. So we're going to take a look at y equals 2 over x. So the first step, as before, when we're finding extreme values, you need to take the derivative and set it equal to 0. So go ahead and do that. What's the derivative of y equals 2 over x? You should be able to figure that out. Go ahead and pause and do that and set it equal to 0. Okay, so when you're doing the derivative of y equals 2 over x, remember that's the same thing as 2x to the negative 1. So if you think about it that way, okay, you got an exponent of negative 1. So you bring that out front, you're going to have negative 2, and our new exponent will be x to the negative 2. So the way we'd usually write that is negative 2 over x squared. Instead of having an x to the negative 2 put on the bottom, and we're setting that equal to 0. So if we want to solve that, I got negative 2 over x squared equals 0. So I'd multiply both sides of my equation by x squared, so that it's no longer on the bottom. And if I do 0 times x squared, I would just get 0. So I'd end up with negative 2 equals 0, which would be no solution. There's no place where this derivative equals 0. Which brings us to something we haven't talked about yet, a little bit different. As we're evaluating these, we set our derivative equal to 0, but there's also another type of critical point that we would want to examine and check out what's happening at. We'd also want to examine the domain problems of our derivative. Anywhere where we might have a domain problem, we'd also be checking that point out, as well as where the derivative equals 0. So if I look at that derivative, negative 2 over x squared, our domain problems, values of x that you cannot put into the function. Well, our main domain issue here would be that you can't divide by 0. We don't have any even roots or logarithms, so we don't have to worry about those other domain issues. We can't divide by 0, which means we'd have a domain problem when x equals 0. So that's what we're going to have to evaluate as we look at, when is it increasing or decreasing? Is there a maximum or minimum? We're going to take a look at that domain issue. And usually these domain issues are not going to be maximums or minimums, but it could be a point in our graph where it might change from increasing to decreasing depending on the graph. So let's take a look. So this time my number line, I only have 0, makes it a little bit easier. And I'm going to look at the derivative of our function to find out if that slope is positive or negative, increasing or decreasing. And I can pick any value I want that's less than 0, anything greater than 0. I'm going to plug that into the derivative. So I'd probably just choose negative 1 and positive 1. And then you're going to plug those into the derivative. So do that quick. Figure out if you get a positive or a negative number. If I plug them in there, you get negative 2 over negative 1 squared or negative 2 over positive 1 squared. Those are both just going to be negative 2. So we get negative numbers in both cases in this one. So it's a little bit different than our previous example. Maybe a little bit less exciting. If I look at the graph, then the graph would basically be, it would be decreasing, it gets to 0, and then it's still decreasing. It doesn't change, so it's not flipping over, and that's not a minimum point, that's not a maximum point. If we think about what a graph of 2 over x would look like, that would be like an asymptote line on our graph, where the graph jumps. In this case, it'd be jumping from negative infinity, and then on the other side of 0 would be up at positive infinity. So it is moving and changing, but there's not a maximum point there, and in this case, it's not changing between increasing or decreasing. So if I want to write out my extreme values and my increasing or decreasing, since it's decreasing on both sides of 0, then we can't evaluate it at 0. There are no extreme values on this particular graph. Then for increasing, well, I didn't get positive on either side, so increasing, there's none, never, however you want to put that. And then for decreasing, we could, you don't necessarily want to say always, because there is that 0 point we're just looking at, and at 0 we can't evaluate it, we don't know, it's not actually decreasing or increasing or really doing anything, it doesn't really exist there. So the best way to put that would be that it's decreasing when x is less than 0, x is greater than 0, or you could say when x is not equal to 0, which would just imply for any value of x other than 0. And that would be our extreme values and our intervals of increasing and decreasing on this one. That was a little bit different than our previous. So now it's time for you to go check out your assignment. Do make sure if you read the directions, I think some of the directions may tell you that you need to work things through analytically, which is how we worked out these couple examples. Some of the directions may tell you that you can work it out graphically, in which case you can just type it into your handy dandy grapher and look at that graph and use the tools on the graphing calculator to figure out extreme values and your eyeballs to look at where it's increasing and decreasing and such. Or you can do it analytically if you want. That would be up to you. So good luck with that and get to work.